Students who are in the online, am I audible? Online students. So now I will move to the further. What is the use of constructor? To initialize the object. To initialize the object. Next, what are the properties of constructor? Constructor name must starts with underscore underscore init, underscore underscore of init of self and then some parameter names. And constructor automatically called by PVM during object creation. Constructor will not return any value except none, except none. And constructor can be inherited and constructor can be overridden also. Okay, that is about constructor properties. And constructor definition also we got it. Constructor definition also we got it. Purpose also we understood. Types of constructors also we got it, right? How many types of constructors? Two types. One is default parameterizer constructors. Okay, done. Now today I'm entering into the another kind of concept. So next area I'm going to discuss, students. Go to the place in E colon. In this place, we already started with yesterday. Where the OOPS concept is available in that index of OOPS. Carefully follow. Classes concept done, object done, constructors, and today we are going to introduce what? Destructors in OOPS and with what? Garbage collector. This is the point I am going to discuss. Do you know what is the destructor? Do you know what is the garbage collector? What is the garbage collector? Madhubavulu. I'll go to my class where I taught to you. Go to 6 p.m. Go to 6 p.m. Very long back when you are in LKC. I said features of Python. Features of Python. There are the features of Python. In the features of Python, simple feature which I taught almost 16, 12, 20, 23. 6 o'clock, 8 minutes I said. In Shubha Muhurta, I said that. Last year almost. I will open that and see that. See this. Time also, yes. Now see students, factor number two you see students, Python programming provides inbuilt garbage collection facility there so that collection collects unused memory space and improves the performance of Python based application. Hence garbage collector takes care about automatic memory management. Automatic memory management is taken care by what? Garbage collector. Definition I said, a beautiful definition. A garbage collector is one of the predefined program and whose role is to collect or remove unused memory space and improve the performance of what? Python based applications. This is what I said in the 16/12/2023 at 6 o'clock 8 minutes I said. And you almost forget everybody. And boys completely all become senior citizens. All boys become senior citizens. I don't know if your stick is parking in cellar or not. I don't know. Almost you are coming in almost perfect laziness you entered. So this I said. Coming to the point back, this almost I said, and this point I am going to show practical in the class. While I am explaining this concept, I said already in the class, I'll show this program in the oops destructor concept. That time I said, because you did not remember, you are busy working in CMO office, PMO office. You're busy now. So that's why. Now I'm going to show you this examples today. How garbage collector runs. Now I'm going to show you this. Shall we start up? Go. To our concept today, what I'm entering now. So destructors and garbage collector. Now I'm going to start with. Students, I'll go to the PyCharm. Go to the PyCharm here. Start here. Coming to this place, do you remember variable rules? Hmm? Do you remember variable rules? Huh? మిమ్మల్ని చూస్తేనే అర్థమవుతుంది నాకు బాయ్స్ చూస్తేనే అర్థమవుతుంది. By looking at boys in the class, I'm feeling very much pretty about them. Because they are feeling how many things we have to remember like that. When you come to the point, boys, there is no way for you. You have to remember. Constructors done. Now I'm going to start with what? Destructors. So I'm going to start with what? Destructors. So I'm going to say 6 p.m. Better I will write 6 p.m. Oops, I will write it. So there I will start all the things I will show you here. Now students, now I'm going to start with now here entering like this. Now I'm going to take up here. I'm going to take up one program now. What is our agenda here? Destructors. Now coming to the point of it, non-destructor example I am going to tell you. First, non-destructor example. Non-destructor example 1.py. Non-destructor example 1.py. Lohit, good student. Now I'm going to say, is saying that all the variables valid, invalid is saying that. So today, of course, any new incident is there I used to share with you. So one faculty from UK, I said already, is there with me. And one more, Rohit Saxena. Rohit Saxena. Rohini Saxena. She's a madam. She is also faculty for Java. And is saying, of course, maybe she asked some doubt, it seems earlier, 3 to 4 days back. That day she did not introduce by herself. Today I taught rules of variables. What is my last rule? Case sensitive. Capital H is different from small h, case sensitive. And that Rohini Saxena madam is saying in Java, is she saying I'm a faculty for Java? I'm a faculty for Java. We cannot use capital variables in in Java. If you use capital variables, you will get error, she is saying directly. She is a faculty now. I opened immediately Java. Java software I opened. She's saying moreover, I'm a faculty. So faculty means something is there. I entered directly to Java software. I shown directly Java place I went. I like this only I went. Because I want to give left and right to such wrong things. I don't like that. Because if that strongly saying that, they need to show programming. Because of that only, students are getting problems in their career. Run as an administrator, immediately I opened this. Immediately I opened this. Then I said, int, she is saying age is equal to 99. This is valid. Now she is saying int capital age is not possible, she is saying. Not possible, directly not possible. In the classroom also she will tell like that only, na? What student will do? Madam is saying, Rohini Saxena madam is saying, okay, saying like that. Now I typed it, int capital age is equal to 98. Giving answer or not? I shown this. Immediately she becomes silent. I said directly in the class, something we don't know, we have to learn. We should not tell I am a faculty. It is like that. She should not dictate the terms. She, she should learn, correct or not? So if they say like that, how many students spoiled already? And I asked after, before showing this, I know this will work out. Later I said, I am also 23 years I taught Java. I hired in that. So I asked how many years experience you have as a faculty. She said 9 years. 9 years onwards, how many people gone to garbage collector? See, students, this is what the faculty problems. Faculty will not have something like that. It's normal only. And coming to the point of it, who is this? Rakesh Babu. Yes, good, very good student. Rakesh Babu is a very good. He is saying rules of variables. Uh, so, like that, people are asking this type of things. The moment I shown, na, no more doubt. I called, Madam, where are you? I said, Madam is not there. She said, thank you, sir. She said, after 2 seconds, no sound. She is saying, moreover, sir, I studied in one book, he is saying. I said to her, don't study books. Don't study books. Don't study books, I said. Correct or not? Correct, exactly correct. Then what to study? So I said, tomorrow I will tell you. She said. So this is more than enough. She cannot sleep also. Why? 9 years, he said something like this. All of a sudden, star shown like this. Out. Like that. If we are confident on subject, we have to come to teaching field. Otherwise, we should not come to teaching field at all. Because on teacher, so many people depends or not. Like that. Shall we start now? Yes. So now, hmm, Giridharan, in theory, they are telling case sensitive. They are applying it in their own way. Oh, like that, Giri. So, because in textbook they will write something, they will understand something. When it comes to student, it will become nothing. That is what problems are. Madams are really danger students. What I have seen. That is my opinion. Today also it proved once again. Really, they are danger. That's why don't go to teaching field. If you go to teaching field now, you'll get lot of problems. Boys will get problem. Yes. So, correct, boys? Yeah, very good. Thank you for your support. Because even I got three, four madams in my career, very danger. I don't look at them also. Really. So now, this madam also there. She is there in my entire class. She is there. She said, after showing this doubt now, she said, last word. Sir, I read in one book, sir. And one more word, why she said, I don't know. Sir, I paid the fees already, sir. Thank you, sir, she said. I don't know why she said that word of paid. No problem. Paid or not paid, I don't ask any student. Will I ask her? No. I'll show the subject directly. Okay, students, problems may be there. Let us enter into the topic. Now set. So, non-destructor example 1.py. There I set. And one ultimate faculty is there. Mohammad Walid is from UK. He said today also he is economics professor. Economics professor he is. He want to switch over to the Python because he want to learn data analytics, data analysis, and Python. He want to become data engineer. He's an excellent guy. Whatever I am saying now is grasping and asking. Very good person. I really like that. That's why. Come to that. Girls, madams are really danger. So, so, hmm, Vani. Vani is also saying something. Supporting to her or not, I want to see. In 9 years, he did not ride one. Yes, Vani, correct, ma. What you said is correct. In 9 years, he did not touch the laptop also. Correct or not? So, come to the point. Anyhow, on unnecessary things, discussing is waste of time. But I want to share that views to you people because I cannot share with anybody, right? Except to you. Anyhow, come, class, employee. I'll take employee here. I set DEF. I will take underscore underscore init underscore underscore of self. Self. I said self. Now, in that place, I will write, in this place, I will write ENO comma ename I said, ename. I forget which constructor it is. Parameterized constructor. Parameterized constructor it is. Print, I am from I am from default constructor. I am from default constructor. Parameterize constructor. Because the girls are sitting in front of me now, that's why that inherited properties are coming. I am from parameterized constructor. Self dot what? ENO. Self dot ENO. Now, while I'm typing, I'm thinking why madams are like that. That's why the moment when I think madam going wrong. Self dot ENO is equal to ENO. Next self dot what? E name is equal to, or name is equal to E name. This is my data. I'll print here. What I'm printing? EMP number. EMP number. Students, carefully follow. Dot format of what? Come on, students. Here I am writing self dot what? ENO. Got it. So next I will go to print of what employee name, print of EMP name, employee name. I'm taking dot format of what? Self dot E name or name I will say. This is called what the information related to this. And end of this I will say. End of this I say. This is called what? Constructor, that you already aware of it. Students, online students, carefully follow. What I do? EO1 is equal to employee of 100 comma what? RS. Online students, follow. So this is comes under which one? Object creation. Makes the PVM to call what? Come on, ma. Makes the PVM to call what? Parameterized constructor. EO1 will go to self, 100 will go to this place, and a name will go to this place. Understand, students? Online students, carefully follow, ma. Quickly try to answer. Now you got it. Now you got it. What is the meaning of this entire thing? So run this then run this point, and you got the output also. Parameterized constructor, number and name came. Now, students, I am trying to ask you a question here. Once this program execution started, I will write on the top of it, program execution started. Program execution started. Execution started. And program execution ending. Program execution ending. Here I am writing program execution ended. Here I am writing ended. Ended. See, students, run once again. In this place, program execution started, program execution ended. What did you understand with this explanation? When the program execution started, object created. When the program execution ended, the OS will remove the memory space of the object EO1 allocated. Correct or not? For EO1 is concerned, some memory space created now. As long as my program is in execution process, the object is containing the memory space. Once line number 14 is executed, my program is nowhere else required to execute the statements, right? It is removing the memory space. Who will remove the memory space? Garbage collector. So garbage collector internally calls one new function. That new function name today called destructor. We are calling what generally garbage collector, garbage collector. Garbage collector internally calls what? Destructor. That will destroy the memory space of the object which you created. Catch this point. Who will call the destructor? Yes. Garbage collector is the one which is running behind of my Python program, whose role is to collect what memory space? Unused memory space. Once my program is over, whose memory space has to be removed? EO1 memory space has to remove. Who is removing the EO1 memory space? Garbage collector. Garbage collector in turns calls what? Destructor. So tell me, constructor called by whom? Constructor called by whom? PVM. Constructor called by whom? PVM. Destructor called by whom? Garbage collector. Compulsory question. Program execution started. Object created. When object created, who will call what? PVM calls the constructor. So that object created, memory is created, data is initialized. We use that data, we perform the operation, program execution completed. Who will come into picture? Garbage collector, which will destruct which memory space? Object memory space by calling what? Destructor. Hence, every garbage collector already contains what? Destructor code inside of what? Garbage collector. That means a Java programmer or Python programmer or .NET programmer need not to write what code? Destructor code need not to write it, because garbage collector already defined with what code? Destructor code was already defined. But when I say this sentence, definitely as a student, if I am a student, I'll ask my sir, sir, show me once, sir. Show me once, sir, how it will be. I just want to show you. Okay now? So don't convince any topic or any faculty unless and until they show the program. This is my advice to anybody. Okay now? I'll create one more object I will create. EO2 is equal to, I am writing here, 200 here, 200 here. I am going to say here something like what TR I am writing, TR. I am writing TR here. And one more object I am going to create it. EO3 is equal to of writing 300 here. And I am writing something like, MC, I am writing it. These are called what? Three different objects are created. Three times this memory space is created, three times initialized. Once a program execution is ended, the memory space which is created for EO1, EO2, EO3 automatically eliminated by the garbage collector. If I run my program, happily that results are coming. Program execution started. First time executed, second time executed, third time executed, ending is taking place. Are able to follow? Now, here, no destructor, nothing I written it. But still, internally calls what? Garbage collector calls what? Destructor. Sir, can you show me whether it will call or not? We want to see once. Now, for that, I am going to write another code. This is called what? Non-destructor. Nothing is there. Now I am going to enter into the destructor kind of code. Dear students, what is the syntax for constructor I said last class? Come on, tell me once. DEF. Syntax for what? Constructor. Syntax for constructor. I said last class. Tell me. DEF underscore init underscore of self, comma, list of formal parameters, and we'll write the block of statements doing what? Initialization code. Right or not? But today we are going for what? Syntax for what? Destructor. Actually, syntax for destructor. I am writing the best process here. I will write DEL. What is that? DEL of what? Self only. It never takes any one of the parameter, because it will remove the complete object data only. So DEF underscore del of this one. I will just write a message over there. Actually, while you are dealing with real-time applications, it is not recommended to write the destructor by yourself, because 1 hour, 30, 40 minutes, I'll go on showing different various examples on destructor. What are the things we are getting? At the end of the class, we'll become so perfect in destructor. What is the syntax for defining the destructor? DEF underscore del underscore of self. Who will call this destructor function? Very good. At what time? At the end of the program execution. That is known as what? Automatic garbage collection. What collection? Automatic garbage collection. Sir, can I call in the middle of the program also? Yes, we can call. That is known as what? Forceful garbage collection we can call. What is that? Forceful garbage collection. How many types of garbage collections? Two types. One is automatic garbage collection, forceful garbage collection. Automatic garbage collection meaning is what? At the end of the program execution that will execute, Forceful garbage collection means what? In the middle of the program execution also, I can make it to execute. So how many types of garbage collection executions? Two. One is automatic garbage collection, forceful garbage collection. By default, what? Automatic garbage collection. Let us go to PyCharm and carry this example. I'm going to take up here. I'm going to write it. Carefully try to follow. Now I'm taking example2.py. Example2.py. See students, now I'm going to carry this example. As usual, I will carry this example students. Carefully try to follow. I will get it. Now I'm going to enter into this place. Try to follow. Here I'm writing destructor example. Here I'm writing. Now I'm saying here. There I'm writing in this place. Program for program for demonstrating what? Garbage collector. Garbage collector I'm going to take. Garbage collector by calling what? Destructor. So keep in mind, it is also one of the MCQ. Who will call constructor? PVM. PVM. Who will call destructor? Garbage collector. So here I wrote what? Init. Next I'm writing what here? Destructor I'm going to write. DEF underscore del underscore of self. See, my dear student, already this type of code was present everywhere. This type of code was present with everywhere. Just I am writing what? Self. I am writing self. Now, here, we need not to define any code. Just I am showing you how it is executing. Print of what? GC calls. GC calls. Underscore del. Underscore del. And memory space. Memory space removed. Memory space removed. Only just I am writing. In real time, we never write destructors in the program. Why? Already destructor code was defined in where? Garbage collector. Even if you write, it is not going to consider your code for eliminating the memory space because they are already written to take care about the performance of real-time projects. They already defined what? Destructor kind of code. I'm just writing only for your understanding purpose how it will execute. I'm just saying it. Shall we run this code? Come on now. How many objects are created? Come on. Three objects are created. Three objects are created. After creating three objects, line number 15 started. Line number 16 constructor called. Line number 17 constructor called. Line number 18 constructor called. Next, what is happening? Line number 19, program execution ended. The moment when program execution ended, it is the responsibility of the garbage collector which is running behind of my program called a destructor example one. One program is running. What is that program called? Garbage collector, which is running, that will eliminate the memory space of what object? EO1, EO2, EO3. EO1, EO2, EO3. How many times this destructor is calling the garbage collector is calling the destructor? Three times. For EO1 one time, EO2 one time, EO3 one time. Shall I show you that? Let us run this code. And you will get immediately that memory space, immediately this garbage collector will call. If you want to pause some time dot sleep of what? 10 seconds. 10 seconds. I'll import the module called what? Import. What is this now? Time I am going to say. Import time I said. Try to run this. After the sleep 10 seconds, carefully try to follow. See now, program execution still it is available. Program execution is ended. Cursor is blinking. After 10 seconds, garbage collector calls what? See, GC calls underscore del, memory space removed, memory space removed, memory space removed. Are you able to follow? Whose memory space is removed? Memory space removed for first object, second object, third object. Are you able to follow? Memory space removed. Whose ID is equal to ID related memory space. Which ID related memory space, students? ID of ID of what I am writing? Self. Just I'm showing the memory space removal also. Now see students, carefully try to follow. After 10 seconds, three different addresses will come, three different memory spaces removed by garbage collector. Is it coming three different objects memory spaces removed or not? Hence, any object created at the end of the program that will be removed. Who will remove that memory space of the object? Garbage collector. Garbage collector internally calls which code? Destructor. That will destroy the memory space of that. You've seen practically this. But am I getting any special award by writing this type of code in my real time? Nothing. Even if I take my special program like this, no need to bother about the destructor code. That's what I said. Garbage collector automatically takes care about what? Memory management. Getting or not? Let us move to the further students. I will move to the further. Here I got it. Online students, did you understand the perfect theme of this garbage collector? Quickly, all of you try to respond. Now I am entering into the further. Each object will take how much memory space I want to compute. Three objects memory spaces I will take it. Let us carry this example. Let us see multiple examples and you will get very perfect knowledge here. Under 2.py, 2.py, try to carry, what is this? Destructor, okay, 2. I will take it as what you know. 1 I will take it. DEST, destructor example 1.py. Destructor 1.py. I will carry this entire example and try to follow. While I am submitting to you, while I am posting, I will change it. This is 2, I will make it. That is 1, I will make it. Following? Let us, in this program, I will find the memory space. Right now, you don't write it. For a minute, you don't write it. I will find the memory space first step. I will find the memory space. Come on. How to find the memory space? Find the memory space of an object. Memory space of an object. It is also one FAQ in interview point of view. How to find the memory space of an object? Tell me. How to find the memory space of an object? ఎందుకా మీరు అసలు? Why? Why you are? So, coming to the point, but I will say sys dot get size of. Get size of. I will pass it what? EO1. This I was explained in NumPy. NumPy. Go to once in this place because I want to wash out your brain once as long as you are present in my class. When you come to this differences between differences between differences between and traditional Python list and all those things. If we come to this place here, in large samplings of data, list-based applications takes more memory space and ND-array object takes what? Less memory space. In the beginning day, I measure the memory space of list. I measure the memory space of ND-array. Did you remember? Less values, list got less memory and ND-array got more memory space. And for large samplings, list got more memory space. The ND-array got less memory space. Explained already? You've seen in my class? Why don't you remember? If I say anything, sir, you'll say, I'm a student, sir. So what? Student means don't remember. Student means always studies. Student means always studies. నేను దానికి సంబంధించిన ఎగ్జాంపుల్ కూడా చూపిస్తాను మీకు. Examples. Now here, somewhere else, I already written approaches for creating. Somewhere else there is a approaches to do combinations. Somewhere else, these things, if you go for it, random set operations, statistical operations, permutations, combinations, indexing, slicing operations. Somewhere else I already random creating number of objects. Somewhere else there is concept is available. I don't know where I said to you. Set operations, outer, etc. Maybe in this case, I hope it is available. I think so. Now it is available. Here it is available. Yes, here only. Maybe that is spot is available. Data type memory space is created. So here I said maybe in the beginning days, while I'm explaining the advantages, that day I was explained this concept. If you remember, all of you knows, I think so, that this example I already explained. Explained now? Yes, explained. So that I am using today. Anyhow, I already explained. Size dot what? Get size of EO1, which is going to give you what? Total memory space, TM. Yes, Vani explained. Good. Print of what? Memory space of memory space of what? EO1 is equal to EO1 is equal to, now I am writing TM I am writing. So how much memory space is taking for EO1? You just try to remember. 40 or 45 or 47 or 48 or 100 or how much you need to see, you try to get it. So what is happening? Memory space of EO1 is what? 48. One object 48. Three objects means what? 48, 48, 48. Calculations problem. So 144. 144, you know? Yes. So that I will go for what? Plus I will take up what? EO2. EO2 I will take it. Plus what next? EO3 I will take it. Then done. Get the total memory space of all objects. Get the total memory space of what? All objects. Okay, I got it. I'll print the data, students. What is this now? Total memory space. Follow me. Total memory space. I'm going to take total memory space. Initial total memory space. Total memory space of what? All objects. All objects is equal to what is my memory space printed? Comma what? TM. TM. What is this TM here? Which is a variable used in where? Main memory. Now I am writing today. What is the code I am writing? Well, DEF underscore underscore del. Now I am writing. Here I am writing underscore underscore of self I am writing. In this place, as I said earlier here, GC calls. GC calls. What is this? Underscore underscore del for mm, for deleting, for removing the memory space. For removing the memory space of what object? Current object. Current object. Whichever object is removing, whose current memory space is removed. Understand this point? Tell me now. How do you remove? How do you see that memory space? What is the total memory space printed? What is the total memory space printed? 48 plus 48 plus 48 is called what? 144. When the program execution is completed, when the program execution is completed, what will happen? Which object memory space is destroyed? EO1. EO1 or not? When EO1 memory space is destroyed, how much memory space is left out? 144 minus 48. 96. 96. Second object memory space removed. 96 minus what? 48. How much? 48. Third object also removed. What is the memory space? That means total memory space cleaned or not? Garbage collector clean up the memory space which is used or not? Then how to do that calculation? Tell me. Where is the total memory space is available? TM. What should I do now? What should I do now? TM is equal to TM, TM minus, TM minus, TM minus. ఎందుకు మీరు అసలు సిస్టర్ డాట్ get size of self, get size of self. Why? When EO1 is removed, EO1 reference is present in where? Self, whose memory space I am getting, that I am keeping into TM. And TM is what variable? Out, global variable. Any variable used in main program which I am using in the entire program is called global variable. Since I am modifying the global variable, I will use what? Global TM. Global TM. Global keyword. Explained or not? మనం అంతా explain చేస్తాం. We will explain everything, but here required brain has to work. So Tm minus sys dot what? Get size of. Get size of. Now I will print now available memory space. Now available memory space, I will write it. Now I'll write now, now available memory space. Now available memory space. Now memory space I will write. That's all. What is that now? Tm 144 minus 48, 96. 96. Next time when another object is removed from the main memory, 96 minus 48, like that. 48 minus 48, 0. That is becoming what? Program execution ended. That is the calculation will come. Are you following me? So I'll say what? Time dot what? Sleep of 10 seconds. Here I will import. What are the modules? Import sys, import time. You can write in same line, even you know that. Online students, did you understand this calculation? Did you understand this calculation, both the places? I hope you are getting it. And this is for what? GC calls the destructor for removing the current object. If you are very much interested, you can print what, students? ID also you can print. ID of what you can print? Self, for your better understanding. Let's run this code. Beautiful. See this output now. End of this total memory space in the 144. After 10 seconds, see the answer now. See the answer, my dear students. Perfect. So the answer is what? Program execution ended. GC calls del for removing the object memory space. First object memory space removed. Memory space left out after first one, 96. Second object removed, and whose memory space? 98. Third object removed automatically, whose memory space left out is 0. Am I removing or automatically removing? Is it necessary to write destructor in my program? No. Who is taking care about automatic memory management? Garbage collector is internally calling destructor. Who is the actual destroying the memory space of an object? Destructor. Destructor is linked to whom? In where it is linked also, I will tell you when I come to inheritance. Inheritance is the next chapter. Where, how this destructor and this garbage collector, where both of them are present also, I will explain. Did you understand? So what is the question? Garbage collector calls what? Destructor. Constructor called by whom? PVM. Initializing the object done by constructor during object creation. After the program execution is completed, who is calling? Garbage collector is calling the destructor and will destroy the memory space. Following or not? Fine. Coming to the point back. Now I am going to have a conclusion. Now this is called memory space calculation system I shown you. Is it understandable? Now please read out our beginning sentence of destructor. Destructor and garbage collector definition. A garbage collector is a program, Python background program, running behind of a very regular Python program, whose role is to collect unused memory space and improves the Python based applications. It is going on removing the memory space when the program execution is completed. Clear or not clear? Clear. Let us move to the another explanation part. Students in online, I hope you are satisfied with the definition of garbage collector, what I taught, and today I shown you programming. Next I am entering into the another example. Carefully follow me. Now I am entering into one more example. Destructor example 3.py. Destructor example 3.py. Students. Now I am going to carry this point. See students, anything you carry, this I am going to write it. Here I am going to write down 3.py. Here I am writing destructor. Total memory space is available, and this is already done it, and this case already done. Now I am going to remove because you have seen the memory space. Something new model I want to tell you here. This you remove it. And this is a destructor defined, constructor defined. Dear students, memory space anyhow you have seen it, that you remove it. Here you remove it. Now this also take care. Students, you observe it now. Carefully try to observe. How many objects I have? 3 objects. For example, I created line number 20 an object which is in use. The memory space is in use from line number 20, 21, 22, 23. And then in 24th line only, the memory space of what EO1 is getting removed. Are you following? Suppose I have a very big lengthy code is there. My number of lines of code is called 1000 lines, for example. In 10th line, there is an object is created. In 1001 line, there is a destruction of the memory space is taking place. In 10th line, there is an object created whose purpose is completed in 15th line up to 15th line, whose purpose is completed. But then that means from 16th line onwards, I am not at all interested to maintain the memory space of what object which is created at which line? 10th line. But I am still maintaining the memory space from 16th line to what? 1001 line. Is it not waste of memory space? Unnecessarily, I am keeping much overhead on the head of the PVM. I don't want to maintain unnecessary memory space. If the more memory space hold my program, unnecessarily lot of resources are consumed internally. It is taking lot of heavy weight to maintain unnecessary memory space. So the moment when 10th line to 15th line, my object is no need, then and there I want to eliminate my object memory space. Are you getting or not? Are you getting my point? So here, I want to go for eliminating the memory space of an object when object work is completed. With that object, no more work in the further lines. What I will do? I need to call the destructor that time or not? In the middle of my program execution, I am calling the destructor. Please come and collect what memory space? Unused memory space of that particular object. That is known as which kind of garbage collector? Forceful garbage collection we can call. Are you able to follow? Forceful garbage collection we can call. Getting or not? So what should I do now? What should I do for that? For calling the garbage collector forcefully. In previous program, which type of garbage collection it is? Automatic garbage collection. Automatic garbage collection. I'm just mentioning. In the notes, anyhow, I'm going to show you automatic garbage collection. In this program, I'm going to show you what? Forceful garbage collection. Look at in the line number 21, I'm writing one sentence. Print of no longer interested, no longer interested, no longer interested to maintain memory space of which object? EO1 object. That means immediately I want to remove what? EO1 object. How to remove? To remove an object, to make the garbage collector to collect my object memory space. The simple thing is what? EO1 is equal to what you will do? None. None. What is the use of none data type? Now this is the use. None data type is used for what? Representing no value. When you say L1 dot empty list, L1 dot clear, what is an output will come? None. Dictionary. D1 dot get off the key I am passing when there is no key is available. What is the value returned? None. You did not remember all these things. I am remembering that. D1 dot clear, D1 dot remove and all those things. If any go for it, if we go to that, none will be returned. Go to this 6 p.m. Go to 6 p.m. Data types if I take it. Under that none data type, if I take it, under that none data type, you see none is equal to what? This one you see none type data type. None type data type is not 0. None type is not false, etc. You said. Any kind of value not returning anything, which is going to say what? None. Reverse of, I keep it into left side variable, none is going to come. So this type of example, I already said to you in my previous classes. Now, if I come to this area, what I'm trying to say, when you assign none to the object, automatically what will happen? Automatically what will happen? Makes the GC to call. Makes the GC to call what? Destructor. Makes the GC to call destructor. What is this? Forcefully. forcefully in the middle of the program execution itself. Got it out? Now, students, now I am writing some small statement I am writing for you to understand some 5 seconds I said. Next, I will write one more sentence, student. What is the next sentence I am writing? Here also I am writing. No longer interested to maintain the memory space of what? EO2. And I am writing here EO2 is equal to what? None. Makes the GC2 call destructor forcefully. And EO3 I am not writing. EO3 I am not writing. Why? EO3 I want to make it to collect the garbage collection automatically. So two objects forcefully and the third object is lost. And I am using automatic garbage collection. Shall I run this code? Are you able to follow, students? So run this now. So carefully you try to run. You see carefully what is happening. After first object printed, see that now garbage collection is coming. I said GC calls del for removing that object memory space gone. And the program execution, second object also called. First object called here, second object also called. Last one program execution is ended. This also called. Are you following? Out of this entire things, what did you understand? What did you understand here? Two objects are forcefully collected and one object is right. If we want that also everything to collect forcefully, I'll go to one more example. Before the program execution only, I want to make it to collect. So I'm writing 4.py. 4.py, I'm going to take it. Take this entire code. Now I'm writing here 4.py. There I'm writing. Here only I'm saying no longer interested to maintain the memory space of this. Here I am writing in this place. No longer interested to maintain. Here I will write something I will call it. I will write it. So done. And time dot sleep. Try to run it. All of them are collected before program execution ended only. Try to carefully see. 5 seconds. EO1 is removed. Next is called what? EO2. EO1 gone. EO2 created. EO2 is also getting removed. EO3 object created. They're also removing. Then removed. No longer interested to maintain the memory space of EO2 and then immediately done. And at the end of the execution, nothing is available. I think it is calling after that. Are you able to follow this? So coming to this point now, I'm going to say, see the program what you have done it. Time.sleep and here EO2 is equal to none. And here you just try to call this spot. Here you try to call. Here you try to call. Just you say something like, some 2 seconds you say, try to run this. Now try to carefully observe it. Final program. Now you got it. So EO1 gone. EO2 created. EO2 also removed. And EO3 created. EO3 also gone. Now EO2. EO2 now, EO3 now. EO3, just mistake. I will just clear it. Program execution ended. Go to the place. Here I will say, go to this place. Now try to see this now. Destructor example 4.py. You just try to see. This is called what? EO2. Actually, I wrote wrong. EO3, I have to write it. That's what I've seen why that is coming like that. 3 you say, don't make it to sleep also. Don't make it to sleep. After that removal, end of that. Execute. Now perfect output will come. Program execution is ending is the last sentence. EO2, EO1 gone. EO2 also removing. Done. EO3 initialized and EO3 destructor is coming. Last program execution is ending. Program execution is ended. What it indicates? What it indicates? Forceful garbage collection. Did you understand? Right. How many objects created? 3 objects created. 3 different objects called before program execution ended. This is known as what? Forceful garbage collection. What is the syntax for forceful garbage collection? Object name is equal to none. One more technique I want to tell you. This is a destructor example 4.py. One more example I want to tell you. for forcible garbage collection. Say this is called 5. So here 5, 5.py, 5.py. I'm going to say, here I can say, coming to this place, here I am writing, this part, 5.py here, 5.py, and I am writing. In place of writing this none, you are saying, how do you delete an object in Python? Go once to the data types, 6 p.m. Data types, data types. Okay, Srivastav, perfect, good student. Data types, list data type, predefined functions in list. Come on, pop, remove, del. There's a del operator, I said, del operator. Del operator. Here, del operator, most important. Applied on mutable object, but not on unmutable object. Del of index-based element, del of slicing-based, removing the complete object. See that? We can apply the del operator on where? Immutable object. When you are removing complete object to remove, I can apply complete object. Indexing and slicing not possible on immutable object like sets and all. Now, that time you can remove complete object. So del operator I will use today. Explained? Not explained? Explained. Everything explained. But మనకు తెలిసి ఉండాలి అది. Del EO1. Del EO1 today. Next is called what? Del EO2. Del EO2. Next is called what? Del EO3. Del EO3. Del EO3. Now getting like this. See this now. Run this code. Same to same output. Same to same output. So no longer interested to maintain. Removed permanently. Second object also removed permanently. Immediately. EO3 removed again. EO3 object removed again. So program execution ended. How many ways are there to forcefully garbage collect? So one is by making object is equal to none by writing del at that object name. So whenever you are forgetting, I am showing in my notes. What did you feel? How did you feel? If I am a student now, I never sleep. I paid 4,000, I paid 6,000 rupees for Python. Sir said everything. I am not remembering. Why? Why I am? Why I am? Did you get that feeling anytime? No? But what you will do by feeling? Need to open the notes now. Correct or not? What I am saying? Something must be there, students. Read, students. So read. So the total life is there because you believed your education. Total life is there in education only. Okay, now? So let us, why I will show you in the class? Just to change your mindset. If anybody change, you can change. In the class, you will feel, oh, today I will read my notes after going to hostel. But when you go to hostel, lot of friends are coming now. That is dominating you. That's the point. That's why you should be there without friends until you get the job. Why friends? What they will do? Will they do anything for you? No. Don't do any friend. So, what is this? Here I am saying. Sukanya is saying, hi sir, and will all memory IDs are same for all objects? Can I see memory IDs are same? Sukanya must write imposition because in deep copy, that is my next example I am telling, which is already I taught in my classes, where I already taught in my classes. Go to 6 p.m. Copy techniques, I said, copy techniques, copy techniques. In that, what is that? Copy techniques. In shallow copy, deep copy, the initial content of both the objects are same. The memory addresses of both the objects are same. Already explained or not? Sukanya already explained, Nama. So now I will explain. Anyhow, even she did not answer. I will explain that example in my class. Why? Because you may get the doubt. Sir, how can we say that when C is asking, you may tell, and how can we say that this you will explain? In my previous topics, you follow me in my 11 a.m. batch. Of course, I need not to prove that I am going to explain because I will explain everything for you. Here we are. It is my 11 a.m. Under that, there is a destructor concept is available. Oops, I will go. Oops, I will go. There is a destructor concept is available. Destructor example 6 or 7 or something. I will show you. Choose another app. I will open this Edit Plus just once. Here you see what is this now? Deep copy. I'll explain or not. See, correct program also I opened it. So even if I go to my home, when I'm eating breakfast also, which file name is what is containing everything. Will you remember? You will not remember where you kept your room keys also. Correct or not? Yes. Come back to the point. Okay, students, come to the point of it. Rakesh Babu, perfect. Come to the point now. Now I'm going to take example number 6. Example number 6, I'm going to talk. Deep copy concept I'm explaining. These are containing what? Different addresses are there. Still not completed. There are a lot of things I want to discuss today. Once we enter into the destructor, and once you get the knowledge of destructor, nobody can stand in front of you. Let us move to the further. Copy this example. Here I am entering. Here I am going to take up. Here I am going to take. Keep all these things aside. Remove everything. Remove everything freshly. What is an object created? EO1. EO2 is equal to what? EO1. Which one? Which one it is? Deep copy. How do you know it is a deep copy? How do you know it is a deep copy? Assignment operator. Because you have seen now, just now. That's why. If I ask originally, sir, deep copy, yeah. When sir last 2023 you taught. So deep copy uses what? Assignment operator. Copy function is in where? Shallow copy. Except what? Frozen set. In frozen set level, deep copy function works like a deep copy. In frozen set level, I said. If I am going on showing now, you will get dislike about your system of study. Frozen set level. So go to once. I'll show you this place. In your place, 6 p.m. and the data types if I open it. Data types if I open it. Set the data type. Predefined functions in frozen set. You see, specially I said what function? Copy function I said. Copy function I said. Here, somewhere else. This point, line number 21. Just to see. In general, immutable object content is not possible to copy in the case of tuple. Whereas in the case of copy frozen set, we are able to copy its content to another frozen set. Here, original frozen set object and copied frozen set object contain same memory address and not at all possible to modify. This is what copy function fs1.fs2.copy. Both of them are containing what address? Same address. See, this is subject. Come. Still time is there. Open today notes. 1 month you read the notes, 6 hours. Over. You will learn Pythonist you will become. Still time is there. Now come to the point. Deep copy. Next I will take what? EO3 is equal to what? EO1. What is this copy? What is this copy? Deep copy. I will print EO1, ID of EO1, ID of EO1. Next is called what? ID of EO2, ID of EO2, ID of what? EO3. All objects contains what address? Same address. Sukanya, try to understand ma because you asked this doubt and see this. Is it containing what address? Same address. Are you following me? So I'll remove this. I will remove this. I'll remove this destructor. Now see, both of them, all of them are containing which address? Same address. Same address is there. Are you following? Now I am asking, I am defining my destructor. I am defining my destructor today. Tell me what I am going to do. What I am going to do? Deep copy. How many objects are there with me? Three objects. Three objects. Then how many times this garbage collector is calling? Come on. One time or three times? One time or three times? One time, because I have shown you already the program. Girls are sharp than boys. Actually, why one time they don't know the reason? Because same address, you will say. Because you are seeing on the screen same address. Sir, you are saying for everything one reason, sir. Okay, maybe you know the reason, but I just want to check it out the bottommost that spark point I want to see. You may be knowing the answer, but I want to see. So now, generally, like this, you try to understand, students. Here I am writing. I will take this EO1 and EO2 and EO3. All the objects are pointing to what? Same. This is called 1, 2, 3. Three objects are created. In deep copy, multiple memory spaces will not create. One memory space only will create, correct or not? So when this total memory space is only 48 bytes only, correct or not? It is not 48 plus 48 plus 48. So what will happen? Is it creating the memory space one time or more than one time? One time, because all of them are identified by what? One address only. Unique identity objects will remove every time, but the same objects are containing. All objects contains what? Same address. So it is going to call how many times? One time only. See that, and the program execution is over. One time only it is getting created. Only one object ID will be created. Are you following me? Now I will ask one wonderful question. If you answer that now, you are very good. This is known as which collection? Which collection this is? Automatic garbage collection. Automatic garbage collection. Are you able to follow? Now, students, go for one more example. Destructor example 6.py. This is 7.py. I will take it. 7.py. Sukanya, did you understand, ma? Did you understand, Sukanya? So you asked this question. I answered it. So now 7.py I am taking. Now coming to the point. Here I am going to take it. This case you take it. Yes, ma, you got it. Good. Now I am going to say 7.py. Now I am going to say carefully try to follow. How many objects are there with me? Three objects. Be careful. Now I am writing very important statement here. I am no longer interested to maintain the memory space of what? EO1. I am writing this statement. I am writing this statement. No longer interested to maintain the memory space of EO1. I said del EO1. Next I will write it what? After that, no longer interested to maintain the memory space of what? EO2. Sleep off. Del what? EO2. Next I am writing what? No longer interested to maintain the memory space of EO3. Del of what? EO3. Now tell me, line number 23, deleting EO1. Line number 26, deleting EO2. Line number 23, deleting EO3. At which time? And of course, you already know how many, even though I written del, how many times it will call? Three times, one time. Boys, already you have seen that one time. Why are you thinking three times or one time? How many times? One time. Why one time? One address. Now at which time? Line number 23 time, line number 26 time, line number 29 time. Line number 23 time, line number 26 time, line number 29 time. 20? Why? Latest. Okay. I'll tell you one example for you. One example, general knowledge example, I'll tell you. So you went to International Airport, Shamshabad International Airport, you went. Three friends went. You find 1 kg of gold bag you found. 1 kg of gold bag you found. This is called an object. Three friends are there, whose name is EO1, EO2, EO1, EO2, EO3. EO1, E1, E2, E3. Three people found the bag, close friends. They said, no need to learn Python. Python gold bag got it. Now they are thinking, it is having only one address or not? Now, this EO1, EO2, EO3 are three friends. Now EO1 felt that. He said, I will go little away. You please, both of them pointing to the same bag. I'm just going away and I'll take some relaxation. I'll go there and I will drink some samtab. I will come back, he said. Okay, go. EO1 went. Here there is a thieves are there, thieves. Thief means where garbage collector is there. When these people go, he want to take away the bag. When EO1 went, is the thief will come and take away the bag? No. Why? Still EO2 and EO3 pointing now. So will the garbage collector calls to eliminate that gold bag there? Never. Why? Still EO2, EO3 pointing. Then EO2 also felt. EO1 went long back. He said, I will also go. I will also go. EO2 is also going. And he want to smoke something. He want to smoke. He went somewhere. And EO3 said, EO2 said, EO3, please wait here only. Don't go anywhere. And EO3 felt very much disappointed. These two people are making me to see this bag. And still EO3, will the thief will come and take away this bag? No. And EO3, he also felt, why I am a lessa? I will also go. I will also drink coconut water, he said. He went away. And nobody is pointing to this gold bag. Happily, thief will come and collect away. And nobody is pointing to this memory space. Then eligible to be collected by whom? Garbage collector. So at which time this is collected? When nobody is pointing. EO1 went out, still EO2, EO3 pointing, not collected. EO2 also went, still EO3 pointing, not collecting. EO3 also went, nobody is pointing there. That time it is eligible to be collected by the garbage collector. At what time it is collecting? No objects are pointing to that memory space. That time it is eligible to collect, even though they are in the deep copy. Are you able to follow? That is the reason. Because of latest, that's why no. Answer should be so perfect. So here, del EO1 makes the GC. Destructor, what is happening? GC here, GC never calls, GC never call destructor forcefully because, come on, EO2 and EO3 points to the object, points to the object. Still, because EO2 and EO3 points to the object. No. Del EO2, what is happening next? Never call. What is happening now? Here. Never call. The destructor. Never call. GC never call destructor forcefully because what is pointing? EO3 points to the object. Next time writing del EO3, at time makes the GC to call destructor because no more objects, no more objects points to object, points to memory space, points to what? Memory space. That time it is going to call. Are you following, students? Clear or not clear? Let us run. See, not calling. No GC calls. Second time also not calling. Third time calling. Why? Nobody is pointing now. Thief will come and take away. Done. Last time only called. Are you following? This is called what? Deep copy participation, garbage collection role. Clarity is there. Ultimately, what did you understand? Is it necessary to write garbage collection code in the Python program or not necessary? Not necessary. Who is taking care about the memory management? Garbage collector. Garbage collector calls what? Yes, destructor code you need to define. Already defined. That's all. Is it necessary to write in my project? No. Now, this is about garbage collector kind of coding. Now I will tell you one ultimate explanation. One more code I will show you. There is a module called students in online. Did you understand all these examples? Did you understand all these examples? Everybody try to respond. Now I'm going to introduce one more small thing. GCEX1.py. Okay. Now I'm going to show you the okay. GC calls the destructor, you understand, because you have written some statement in the destructor that is showing. Now I'm asking you a question. How do you know that garbage collector is running or not? Destructor called by the garbage collector, we understood because you have written some statement inside the del function, correct? First of all, how can I understand that destructor is garbage collector is running or not? How can I show to interviewer GC is running or not? Correct or not? Yes. Now I'm going to show. Now I'm going to show. Here, some small statement I am writing. Program execution started. Just one small execution. Program execution started. SAR says garbage collector is running behind the program. You don't believe anybody unless and until show the examples. Ante kada? That's all. So I will write A is 10, B is 20, C is 30, A plus B. Now I am printing the value of A, comma A. Next I am going to write it. Print of what here, you know, students? Value of B is equal to comma B. Next I am going to write it. Sum is equal to I am writing, comma C I am writing it. Program execution is ended. Program execution is ended. Now I am writing program execution is ended. Program execution ended. Students, now the moment when program execution is started, before that only our garbage collection started. Ready? How can I prove that? There is a module called GC, which is specially designed for garbage collection tracing part. Import, what is the module name? GC. GC is a predefined module of Python only. In GC module, there is a function is called, in GC module, there is a function called what? There is a function called what? Is enabled. What is the function name? Is enabled. The name itself says is enabled. Returns what? True. If it is enabled. If it is not enabled, now it is returning what? False. False means what? Not running. True means what? Running. So I will call that function. Here you go to that. I am writing print of is GC running? Is GC running? I am writing is GC running? Now I am asking a question. GC dot, what is the function name? Is enabled. Is enabled. Returns what? True. See, returns true. Is GC running? True. True, true. That means GC running or not? Like that you can show. Now coming to the point back. Now after the program execution is over, I am doing what? GC dot disable. GC dot disable. Disable means what? You can make it to stop running. After that running, here I am running. Here I am running. After printing this AB, is GC running? Now. Is GC running? I am writing GC dot enabled. What is an answer? False. Why? Disabled. I will print. What I will write it? GC dot what I am saying? Enable. Enabling means what? Again I am starting. After that, what is happening now? What is happening now? Here I am writing. Is GC running? What is the first answer? True. Next middle answer. Next answer. Let try to run this. See this answer. First time true. Second time false. Third time enabled. Are you following? That means GC is just like you are using like your bike. Straight switch on, starting, switch off, it is called false. Are you following? Are you okay? So now I am going to ask you a beautiful question. When you are disabling, is it running or not running? Not, not running. Now my question is, in real time, by mistake, if you call disable, by mistake, if we call disable, will the garbage collector remove the memory space? Come on. No. That time what will happen? When I'm running a big applications in data science or machine learning or any NumPy pandas big applications, if you make by mistake this type of disabling kind of operation taking place, will the memory space removed or not? Generally, student will say no. But actually, strictly speaking, when you disable it, as on today, GC is not under the control of the Python programmer. The moment when you disable it, automatically at the end of the program execution, OS will wait for a few seconds. Is my memory space is completing back or not? If it is not coming back, it will automatically enable the GC. Automatically the OS and existing OS and then PVM will enable the PC, enable the GC, and it makes it to remove the memory space. That means GC is not under the control of the programmer. Even though it is showing false and everything, it is not under the control of the programmer. Sir, can you show it once? I will go to that. Let us go back. Destructor example 1.py. Is it my total memory space or not? Come on, guys. What is the memory space totally? Okay, I will take this example. I will take this example, students. Come on now. I will take a new program, GC example 2.py. See, students, now I am going to take it GC example GC example 2.py. Example 2.py. Here I am writing, here I said something like this. I said, what is this import here? Why this import sys and all those things? Now I am going to take it here, what? Time, and then what next? GC. So remove this entire stuff. Gone. Remove. And first of all, where is the time? No need. Okay. Time is there. And sys is there. Sys is required. Okay. Everything is there. What I am doing now? I will print this statement. Is GC running? Beginning, I am calling. Is GC running? Yes, true. In the middle of it, I am doing what? GC dot what? Disable. Disable, I said. Once you disable, what is this now? Come on. What is this now? After this memory space is printed, what is happening? False. False means what? It stops working, correct or not? But now what is happening? Program execution ended. Time dot sleep. Sleep. Sleep means what? After 10 seconds, what GC has to do? Call the destructor to deallocate the memory space or not? But you made it to do what? Disable. Disable means students will think that what? It won't call the destructor, but it will do what? The underlying OS and PVM, it will observe. Programmer has disabled it. It never consider. It will enable it immediately. Let us execute that. See, students. See, total memory space. Execution. Beginning, it is true. Beginning, it is true. In the middle of it, false. Now see, execution ended. It is automatically calling. Removing or not? Removing. Next is called what? Come down to this. 144 becomes 96. 96 becomes 48. 48 becomes 0. Even though you disabled, it is not under the control of the programmer. Automatically called by whom? Enabled by the PVM and the existing OS. If you make it disable, if a lot of Python applications are running, your total memory becomes out of your memory, main memory space. To avoid the type of problems of hanging problems and then memory problems, even though you disable it, it is automatically enabled. Got it? Did you understand the garbage collector completely? Yes. Please go to our index. See today, destructors in OOPS with garbage collector. Importance and purpose of destructor. Next is syntax for defining destructor. Internal flow of destructor. Relationship between destructor and garbage collector. GC module and programming examples. Understood? Online students? So I am showing the documentation now. I am showing the documentation now. Go to this place. Now here I will go D colon. I will take it by 11 a.m. Once I'll take it, whoops. I'll go to destructor. Notes I will show you. Hmm? Constructor no. So go to where? Destructor. Open the notes and see. Start reading everybody. Come on quickly. We know that garbage collector is one of the inbuilt program in Python, which is running behind of every Python program, whose role is to collect unused memory space, and it improves the performance of Python-based applications. Every garbage collector program is internally calling its own destructor function. The destructor function name in Python is def underscore underscore del underscore underscore of self. By default, the destructor always called by garbage collector when the program execution completed for deallocating the memory space of objects which are used in that program. Whereas constructor called by PVM implicitly when object created for initializing the object. When the program execution completed, GC calls its own destructor to deallocate the memory space of objects present in the program, and it is called automatic garbage collection. Hence, we have three programming conditions for calling GC and to make garbage collector to destructor function. To call destructor function, A, by default or automatically, GC calls destructor when the program execution completed, called automatic garbage collection, makes the object reference as none for calling forceful garbage collection, called forceful garbage collection. Syntax: object name is equal to none. Delete the object by using del operator for calling forceful garbage collection, called forceful garbage collection. Syntax: del object name. Syntax: de of underscore underscore del underscore underscore of self. Conclusion: no need to write destructor in a class of Python because GC contains its own destructor. GC garbage collector module. Garbage collector contains a predefined module GC. Here GC contains the following functions: is enabled, enable, disable. GC is not under the control of the programmer, but it is always maintained and managed by OS and PVM. Python programmer need not to write destructor method or function and need not to deal with the garbage collection process by using GC module because the PVM and OS takes care about automatic garbage collection process. Understand? This is about garbage collection. See, garbage collection beginning only 5 minutes I said. Today, garbage collection almost 1 hour 40 minutes I said. Understood? That too programmatically with a deep copy, with a normal objects creation, with internal flow, with a memory space calculation. After going to home, just half an hour you need to read out. Next day, actually, even I am a student time. When we read today, tomorrow 50% will forget. Day after tomorrow, 75% will forget. That day after tomorrow, completely will forget. After 1 week, we never remember anything. Because automatically garbage collector is running internally. But this is your life now. That's why today if I read, tomorrow not to forget. Once again refer. Today it will take half an hour to refer. Tomorrow it will take only 15 minutes to refer. That day after tomorrow it will take only 5 minutes. That day after tomorrow only 5 minutes. Next day, no need to read. Why? You read 4-5 times now. When you are going to your home, are you writing in a book, take left turn, right turn, U-turn, like that? Are you thinking to go to your home? Directly going by talking in the phone or not? Why? Already you went lot of times to your home, correct or not? Like that. Subject also like that only. More practice gives more knowledge. No practice gives no knowledge. Correct? So the more work you do, the more shine you are. If you don't shine, career is problem. Correct? That's why students, think about it. You know everything what is good and bad. Do things properly. Okay, I'll stop my class. And tomorrow class, when I come back, I will start what? Data encapsulation and abstraction tomorrow I will introduce. So what is the definition of class now? Class is a collection of data members, methods, constructor, destructor. Morning you said class is a collection of objects. You said morning only, na? Today morning or yesterday evening? Today morning. So that time, what is the use of teaching these OOPS these many times? You see any website, OOPS you open it, OOPS tutorials you open it, Python. You cannot understand single line also. There, what example? Dog, cat, donkey. That examples are there. What is the use of that? If you say that example in any interview, donkey, cat, monkey, etc., they will look at who is this. Don't do that. Is that tutorial is having this much of deep notes? No. So you just go through it. So that's why students, when I'm giving notes perfectly, you read that, present by yourself and do that. Okay, students, shall I stop? Shall I stop my class? And tomorrow class, 9 o'clock, 9 o'clock, 6 o'clock, 6 o'clock. And tomorrow morning, I'll already started Matplotlib, Python. What is easy? Python is easier, Matplotlib is easier. Matplotlib, why graphs? Single line, few lines, code is done. Python, so much of code to write. Because behind that entire thing, Python is the main. Correct or not? Yes. So, anyhow, students, I'll start. Okay, ma, Sravanti, I will send you. Actually, morning, some small drive problem is there. It is not uploaded. I hope some problem is there. Now I will upload. Now only I will upload it. Okay, now? Don't worry about it. So nobody asked. Only few students asked, "Are you downloading the notes?" But nobody asked me. Ma, okay. Class అయిపోయింది. Very good. Boys, you did not ask. Class అయిపోయింది. Okay. Very, very intelligent. Okay, students. I hope for the best. I'll upload now. You try to read out. Thank you, students. All the best. Online students, hold on when any doubts are there. If no doubts, you can leave. Time waste. The Panjay part there. Students in online. Am I audible? Online students. Am I audible to you? Yes. Any more doubts you have? You can ask me. Any doubts are there? You can ask me, students. Any more doubts you have? You can ask me. No doubts, huh? So I'm ready to clarify your doubts if anything is there. So if no more doubts, I'll upload these notes for you and download and then write it. Okay, students, take care. No more doubts, no more hand raising symbols are there. I'll upload the notes, download and then write properly. So, Mansi, Vivek Singhi, can I talk to you personally? Um, any subject doubt, ma? Okay, Suresh, I will upload that notes, ma. I'll upload. Data members, I already uploaded. Instance data members, huh? So, Mansi, so can I talk to you personally? You are saying, so any subject doubt? No subject doubt. So, any subject doubt is there? You can ask me. So, regarding what may you know that? So, anything else? Okay, no problem. So, Mansi, no problem. You text to Shubham, no issue. Okay. So, if subject doubts are there, you can ask me. Any other things, you can just, okay, fine. Take care.